Hi friends, welcome to my channel NM Learn Mech Courses with Nagamani. This is the continuation of previous class and we discussed these topics and now I am going to continue with the previous class. Who did not watch previous class, please visit that class first and next continue with today's class. Here I want to explain one thing, that for gamma value is gamma have three values, that is one is gamma equal to 1.4 and gamma equal to 1.67 and another one is gamma equal to 1.33. okay, gamma equal to 1.33. so this gamma equal to 1.4 is nothing but this is for diatomic gases and gamma equal to 1.67 is nothing for monoatomic. So monoatomic gases and this is for diatomic. This is for gamma equal to 1.33 is for triatomic ideal gases. So you have to remember these three values so that wherever gamma value, if it is monoatomic, you can use this 1.67 value. If it is diatomic, then you can use 1.44. If it is triatomic, like you can use gamma equal to 1.33. In this way you can find the Cp, Cv and Cv values. Okay, and next I am going to explain about mixture of ideal gases. And if you see the concept of mixture of ideal gas, that means if we take two ideal gases in one place, so in for any ideal gas which have number of moles and temperature of that gas and pressure, volume, so these are all comes into the situation like mass of the, so first ideal gas is 1 and the second ideal gas we are taking as 2, so mass is m1 m2. And also if we take first ideal gas we will write, so temperature T1, pressure P1, volume V1, like a number of moles N1 and our characteristic gas constant R1. okay, in this way these are the like for M1 gases, and for second gas this is for like temperature T2 and volume V2, pressure P2, number of moles N2. So in this way if a two ideal gases have two different properties, so if we want to calculate overall of these two ideal gas, we can write, sir, for mass we have to add, so total mass is nothing but sigma m, which is nothing but m1 plus m2. And also temperature is nothing but temperature, if we take overall system temperature which is same as like it will come neutral, then it will is constant, so T1 which is nothing but T2. And volume also, which is overall volume is constant, V1 and V2. okay, V1 equal to V2. Next one is pressure. Pressure is to be added, pressure of 1 plus pressure of 2 in this way. And for number of moles also sigma n, that is sigma n which is equal to n1 plus n2. so you can write here sigma n is equal to n1 plus n2. in this way you can write. And if we like wait, okay, I am erasing everything, so I will write overall equation. okay, so if you want, right, we know that ideal gas equation which is nothing PV equal to nRT. okay, nR bar T. so this is only for one ideal gas. If the mixture of ideal gas is there, you have to use, this is the small p, means small me, like one particular pressure. This I am writing capital P, which is P total, like total P1 plus P2, that. And capital V means sum of the these volumes, and which is equal to like sum of the volume is a constant overall, so we can write for small v also. so here a number of moles will we are adding, so sigma n and R bar temperature is constant. So T. This is the mixture equation for the mixture of ideal gases. So while solving problems, you have to remember this type of equations so that you can easily solve the problems. Okay, here I'm going to explain about mole fraction and equivalent gas constant. And here if you see the mole fraction can be represented with xi, and equivalent gas is nothing but R equivalent, represented with R equivalent. So this mole fraction can be defined as it is the ratio of number of moles of ith gas to the total number of moles in the mixture. And this is the formula for mole fraction. And if you see the equivalent gas constant, just here I wrote the equations so that like you can remember these ones. So here I wrote the R equivalent m1 into r1 plus m2 r2 by m1 plus m2, and I will give this is the R equivalent. Okay, next I will explain. Similarly, we saw the R equivalent, so which is nothing but R mixture, which is equal to R mixture, which is equal to m1 r1 plus m2 r2 by m2 r2 by m1 plus m2. We saw this equation. Now I will give equation for CV and CP. Okay, for CV mixture, which is equal to m1 CV1 so plus m2 CV2 divided by m1 plus m2, m1 plus m2. Similarly for CP mixture also, for CP mixture also, like m1 CP1 plus m2 CP2 by m1 plus m2. Okay, m1 plus m2. In this way you can remember those formulas, and if you want you can write in your notes. You can write in every, like you can whatever I am explaining here, the equations, formulas, you write in your notes so that you will remember. So okay, so I am erasing everything here